June 2025 had barely ended when the mystery of 3I Atlas deepened beyond imagination. Every telescope on Earth locked its gaze on the strange interstellar traveler, but the more scientists studied it, the less sense it made. Some claimed the brightness came from a porous surface sunlight, scattering off countless tiny cavities like a cosmic mirror, but nothing natural in any database matched its exact signature. The nucleus was too large for its shine, and the coma around it too smooth, too symmetrical, almost as if crafted with intent. Each new image added confusion instead of clarity. If the surface really was this reflective, it meant one thing: our entire understanding of how interstellar objects survive their journey through the galaxy would have to change. The only instrument capable of solving this mystery was the James Webb Space Telescope, and when Webb finally turned its golden mirrors toward 3I ATLAS, the world held its breath as the object cleared the sun's glare. Webb's mid-infrared instrument began mapping its heat across a full rotation. The data stunned everyone. There were no hot spots, no cold patches, no jets of vapor bursting into space. Just an even, steady warmth like a body rotating with clockwork precision. Every 6 hours, the light curve repeated perfectly. It wasn't tumbling like a random chunk of ice. It was spinning in rhythm, precise to the second. Uncannily steady, said Dr. Corey Sato, the mission's lead investigator. It's almost intentional. Webb's near-infrared spectrograph scanned next, searching for gas. The spectra revealed a coma dominated by carbon dioxide, but diffuse and faint, no concentrated plumes, no sudden flares, no sign of venting powerful enough to alter its path. The nucleus shone through with a mirror-like reflection, confirming what ground observatories had already suspected: a surface smoother than any natural rock should ever be. And yet, even with all that brightness, there was no sign of propulsion, no measurable thrust, nothing to explain how it moved so cleanly through space. For 2 months, Webb and Earth-based telescopes tracked its position down to milliseconds. The results were impossible to ignore. There was no detectable non-gravitational acceleration, no push from gas jets, no pressure from sunlight, no mysterious drift. The object moved as if obeying only one law: gravity itself. If there's an engine on board, Dr. Sato said quietly, it's quieter than anything we've ever seen. That single quote ignited the internet. Was she speaking metaphorically or hinting at something more? Theories flooded social media and late-night news panels. Avi Loeb's artificial origin checklist became a trending topic again: unexplained acceleration, extreme reflectivity, lack of outgassing, mechanical spin. 3-1 ADLAS fits some of those boxes, but not all. The reflectivity was extreme, but not impossible. The outgassing weak, but real. The spin steady, yet not controlled. It was too perfect to be random, yet too natural to be a machine. As the debate raged, data delays from Webb meant for careful peer review fueled suspicion. Why weren't the images being released in real time? Scientists explained the process was standard, but the world didn't care. When an object from another star system shines like metal and moves like a clock, every hour of silence feels like a cover-up. 3 interstellar visitors, 3 different stories. Oumuamua the first came and went like a razor-thin mystery, accelerating for reasons no one could explain. Borisov the second was a classic comet, burning brighter and faster than anything born in our solar system. And now 3I Atlas, a perfect hybrid, a glowing enigma that blurs the line between comet and craft. It carries a vast, even coma like a comet, yet its heart gleams like forged metal. Astronomers now call it a cosmic hybrid, proof that the galaxy's diversity is far greater than human imagination. Each discovery pushes the limits of what we believe nature can create. The next critical moment will come at perihelion, its closest pass to the sun, when radar arrays will attempt to map its structure in detail. If the signals bounce back unevenly, we might see ridges, edges, or even symmetry that no natural process could form. Until then, 3I ADLAS drifts onward, silent and unblinking. Its mystery sealed behind that metallic glow. As of now, its true nature remains unresolved. Maybe it's a comet forged in an alien star system, a relic from a place we can only dream of. Or maybe it's something else, a messenger built long before Earth had life, passing by to remind us how small we really are, whatever the truth is. One fact stands unchallenged: every interstellar visitor challenges what we think we know. And somewhere beyond the stars, something or someone might already be preparing the next. As more telescopes locked on 3I Atlas, the mystery only deepened. Some astronomers argued its brightness came from a porous surface sunlight, bouncing off countless microscopic cavities. But that explanation barely scratched the surface. No comet or asteroid ever cataloged matched its behavior. The nucleus was far too large for the amount of light it reflected, and the surrounding coma glowed with an eerie uniformity too perfect for a typical outgassing event. Each new observation widened the gap between theory and reality. If its surface truly reflected this much light, it meant our entire understanding of how interstellar objects survive their cosmic journeys would have to be rewritten. There was only one tool capable of unlocking its secrets: the James Webb Space Telescope. With 3i, ADLA has finally cleared the sun's blinding glare. Webb's golden mirrors turned toward it. The world waited. Webb's mid-infrared instrument began scanning, mapping its thermal signature across a full rotation. What the data revealed was astonishing. No hot spots, no cold patches, no bursts of vapor, just a calm, consistent warmth. It spun with perfect balance, completing a rotation every 6 hours like clockwork. There was no tumbling, no chaos. "It's unnervingly steady," said Dr. Corey Sato, the lead investigator. "Too steady for a natural body of this size." Next came the near-infrared spectrograph. The instrument searched for volatile gases, and sure enough, it detected a faint haze of carbon dioxide, but diffuse, spread thin, with no concentrated plumes or jets. Nothing that could explain the brightness. The nucleus gleamed through with a metallic sheen, smooth and reflective, almost faceted like light glancing off polished steel. Ground observatories confirmed it. Despite its glow, there was no measurable outgassing powerful enough to alter its orbit. For 2 months, teams across the globe and in space tracked its motion down to the millisecond. The verdict: 3i, Atlas moved under the pull of gravity alone. No non-gravitational acceleration, no hidden thrust. Nothing, if there's an engine on board. Dr. Sato finally said, "It's quieter than anything we've ever seen." That single sentence ignited a worldwide debate. Was it just poetic language or a hint that scientists were seeing something more? Avi Loeb's artificial origin checklist resurfaced online. Unexplained acceleration, extreme reflectivity, lack of outgassing, and a spin or shape inconsistent with nature. 3.1. Atlas checked some boxes, but not all. The spin was mechanical yet stable, the brightness extreme, but not impossible, the outgassing faint, but present. It was an enigma balanced on the edge of reason. Still, the world demanded answers. Every delay in data release routine for peer review sparked new speculation. Was NASA hiding something? Were they waiting for confirmation before going public? In truth, the process was standard, but the timing couldn't have been worse. When an interstellar object gleams like metal and behaves like a machine, even scientific caution looks like a cover dash-up dot by this point. Humanity had encountered 3 interstellar visitors, each rewriting the rules. Oumuamua, the first, thin and fast, with no tail and an acceleration no one could explain. Borisov, the second, a blazing comet behaving exactly as science predicted, but faster and brighter than any before it. And now, 3i, ADLA is a hybrid, part comet, part something else entirely. Its broad, symmetrical coma and mirrored nucleus defied classification. Astronomers coined a new term, cosmic hybrid. Proof, they said, that the galaxy's inventory of objects is far stranger than Earth's textbooks can capture. Each encounter pushes the boundaries of what we believe nature can create. As 3i, Atlas approaches its closest pass to the sun, radar arrays prepare for the next critical step. The upcoming scan might reveal ridges, patterns, or movements invisible so far glued to its structure, maybe even its origin. Until then, the world can only watch and wait. For now, 3.1, ADLAS remains a question wrapped in silence, drifting through our solar system like a messenger from another star, whether it's a relic of cosmic history or a fragment of something engineered long ago. One truth stands firm: every interstellar visitor changes us. It reminds humanity just how much of the universe still lies beyond understanding, and how much of it might already be watching back.